Today's problem 5.5 number 10. Given there is a railroad tie subjected to two railroads, each of P is equal to 175 kilonewton. You have to calculate the maximum bending stress sigma max in it due to the loads P, assuming the distance L is equal to 1500 mm and overhang length 500 mm. So we have, this is the railroad, P load and L distance between them, and this is the overhang. This is the cross section with V and H. Given P 175 kilonewton, L 1500 mm, B 300 mm, H 250 mm, L 500 mm. So given Q is equal, Q whole into L plus 2 is equal to 2P, because summation of forces in vertical direction is 0. So Q is equal to 2P by L plus 2, and critical section modulus is BH square by 6 for rectangular cross section, which is 3.125 into 10 to the power minus 3 cubic meter. So now coming to M1, which is Q A square by 2 is equal to P square by L plus 2 is equal to 17,500 Newton meter, and M2 by the diagram is Q by 2 into L by 2 plus A minus PL by 2 is equal to P by L plus 2A whole into L by 2 plus A whole square is equal to PL by 2 is equal to P by L1 whole into 2A minus A, which is equal to minus 21,875 Newton meter. And this is the bending diagram M1 and M2. So for maximum bending stress, Mmax is equal to 21,875 Newton meter. Sigma max is equal to Mmax by section modulus, which is equal to which is equal to 7 megapascal. So tension is on top and compression is on bottom. Now coming to next problem 5.5 number 12. Given there is a small dam of height 2 meter constructed with vertical wooden beams of thickness T is equal to 120 mm. We have to determine the maximum bending stress in the beams. So given H is equal to 2 meter, L equals to 120 mm, B is width of beam perpendicular to bone, F naught is maximum intensity of load. So F naught is equal to RBH, and section modulus is equal to BT square by 6. So RA is equal to F naught L by 6, and sigma moment with respect to B point is equal to RAX minus F naught X square by 12 into X by 3 minus F naught L into X by 6 minus of X cube by 6L. So for MB max, d mu by dx equals to 0. So F naught L by 6 minus 3 F naught X square by 6L equals to 0, then X is equal to L by 3. So putting this X in equation 1, we get MB is equal to F naught L by 6 whole into L by root 3 minus F naught 6L whole into L cube by 3 root 3 is equal to F naught L square by 9 root 3. So putting this value L is equal to 2 meter, we get MB is equal to F naught 4 into 10 to the power 6 by 9 root 3. So for maximum bending stress, sigma max is equal to Mx by S section modulus is equal to F naught 4 by 9 root 3 into 6 meter square, and putting the values and solving, we get 2.097 megapascal as answer. Now coming to the next problem 5.514, we have to determine the maximum bending stress sigma max due to pure bending by M for a beam having cross section in the form of a circular core. So coming to the solution, this is the circular one, this is the supplying angle beta, this is the diameter d. So from properties of area tables, we get the centroidal moment of inertia Ix is equal to pi r to the power 4 by 4 minus r to the power 4 by 2 whole into alpha minus ab square by r square plus 2ab cube by pi to the power 4. This is equation 1. So r is equal to d by 2, a is equal to pi by 2 minus beta is equal to r sin beta, and b is equal to r cos beta. So Ix is equal to pi d to the power 4 by 64 minus d to the power 4 by 32 whole into pi by 2 minus beta minus sin beta cos beta plus 2 sin beta cos cube beta. And solving this, we finally get Ix is equal to d to the power 4 by 128 into 4 beta minus sin 4 beta. So now centroidal distance y is equal to r sin beta is equal to d by 2 sin beta, because in triangle CP CPR cos 90 minus beta is equal to y by r y by r is equal to cos 90 minus beta, hence y is equal to r cos 90 minus beta, so it is equal to r sin beta. So we know that m by I is equal to sigma by y, bending equation, which implies sigma is equal to my by I. So for beta is equal to 60 degrees, which is pi by 3 radians, sigma max is equal to m into d by 2 sin beta divided by d to the power 4 128 whole into 4 beta minus sin 4 beta. So sigma max is equal to 64m whole into sin beta by dq to 4 beta minus sin 4 beta, and on solving we get sigma max is equal to 10.96m by d cube. Now coming to the last problem, 5.5 number 9, where there is a beam with uniform load q and a rectangular section with b and height h. So q is equal to 6.4 kN per meter, L is equal to 3.5 meter, b is 140 mm and h is 240 mm. We have to determine the maximum stress. So for maximum stress, the formula is mx by s. So first, calculating maximum bending moment, mx is equal to ql square by h, which is 6.4 into 1.5 to the power 2 by 8, which is 9.8 kN per meter, and section modulus is I by h by 2, which is equal to bh cube by 12 by h by 2, which gives us the formula bh square by 6. Hence sigma max is equal to mx by s, which is equal to ql square by 8 by bh square by 6, which is 3 ql square by 4 bh square, and putting the values we finally get answer as that is maximum stress is 7.29 megapascal. Thank you.